Okay, so here we go. 4.3, number 7. I don't have a copy of the sheet in front of me, so you guys help me out. What were the two masses?
2.5 and 3.5.
2.5 and 3.5? Were the masses or the weights?
The masses.
Masses. Which one's the 2.5?
The left.
Left. Okay, thank you. Sorry, I'm apparently terribly underprepared this morning. All right, were they named A and B or 1 and 2? A and B. Okay, cool. All right, everybody good up to there? All right, so the problem tells us that weight B goes down, weight A goes up, and it gives you a distance of, is it 1.8 meters? Am I remembering correctly?
1.8 meters off the ground.
Okay, oh, they're both 1.8 meters off the ground. Thank you. All right, so my drawing is obviously not to scale. All right, so the idea is B is going to go down, A is going to go up, and then question A wants us to know
How long before?
how long before it hits the ground. Okay, so we're trying to find the time, thank you, for it to go through a displacement of 1.8 meters, right? And we can assume, I think it said that everything starts at rest, right? Cool? All right, so there's our setup. Thank you, I'm sorry I didn't have that already. Okay, so, I guess, Elise, you were asking about this. So did you have a sense of where to get started?
Well, yeah, I did do it.
That's okay, that's okay. That's okay. So how did you start?
From the force of gravity.
On the two things, right? Okay, so did everybody do that? Start by looking at the entire system? All right, so when we say the entire system, it's this, right? Okay, and so you're going to have the force of gravity on block A, which is going to be 2.5 times 9.8, which is negative 24.5 newtons, right? Good. All right, you're going to have the force of gravity on block B, which is 3.5 times 9.8, which gives you 34.3 newtons. I inadvertently made this one negative, so should I make this one negative? No. So at this point, we got to decide on our sign convention, and I just sort of did it there by accident, right? The idea is, because block B is heavier, the system's going to go this way, right? So for my system drawing, I'm going to make this way positive and this way negative. Everybody good up to there? All right. Are there any other forces on the system that I need to deal with? I think that's it, isn't it? Those are all of my external forces, right? Okay. So at this point, I can find my net force and find my acceleration. Good? All right. So keep working in right here. So the net force on my system is going to be the force of gravity on A plus the force of gravity on B, which for us is negative 24.5 plus 34.3, and it gives you 9.8 newtons. Everybody good? Okay. So I ought to be able to now use that to find the acceleration of the system, right? So the acceleration of the system is net force over mass. So our net force is 9.8 newtons. What mass do we use, you guys?
6.
Good. Why 6?
So it's both of them.
Yeah, the whole system, 2.5 plus 3.5, gives us a total of 6 kilograms, right? Follow? So divide all of that out, and we find that the acceleration of the system is, it turns out to be like 1.62 or 1.63? 1.63, thank you. Meters per second squared. All right. Everybody happy on that? Anybody confused? I did that pretty quickly. We're good? Okay, cool. All right, so now what the question weirdly, it doesn't even ask us for the tension. I'm a little frustrated actually now that I think about it that I didn't ask that. Okay, anyway, let's focus on the problem. Okay, so now what we're going to do is we're going to find the time it takes for block B to hit the ground, right? So let's write down what we know about block B. So block B has an initial velocity of 0. We know that it's going to go down through a displacement of 1.8 meters. Since it's going down, I'm going to make that negative. Follow? What's the acceleration of block B, you guys? It's 1.63 sorta. Why sorta? Point for me. Which way is block B going to go, you guys? Block B is going to go down, isn't it? So the acceleration from a block B perspective is negative 1.63 meters a second squared, right? So again, I tried to stress this yesterday. Let me re-emphasize that this sign convention that we came up with over here only applies to the whole system, not necessarily to the individual objects. Good? All right. So we were trying to find the time, right? So this is, oops. We're trying to find the time. We're trying to find. We're trying to find the time. So can you guys think of it, one of those kinematics equations from first chapter that has those 4 variables in it? What do you got? Sure, Carter, thank you. There you go. Cool? So we know everything in that equation except for the t. You guys can plug in and solve for t. It ends up not being that bad because this chunk goes away because your VI is 0, right? Follow? Okay, and so your time turns out to be something that's on the answer key. What is it?
1.48.
1.48 seconds. All right. Is everybody good with that? So that was part A. Good? All right. Now, part B wants to know what's the highest height that block A reaches, right? Okay? So, I guess there's a couple things to be aware of. So, here's our original setup. Here's block A, here's block B. They're both, at the beginning, oops, well, that'll work. At the beginning, they're both, oh my gosh. Why is the smartboard being such a, insert word. So they're both 1.8 meters above the ground, right? Okay, so, but they're attached by means of a rope, right? So what's going to happen is, if block B goes down 1.8 meters, then block A goes up 1.8 meters. Right? So at that instant, at the instant block B hits the ground, how high up is block A now? 3.6 meters, right? Everybody good up to there? So that's part of the problem. Okay? The second part of the problem is this. At the instant block B hits the ground, point for me. What direction is block A moving? Up, right? Block B stops because it hits the ground. Is there anything to stop block A?
No. Gravity. Well, yeah, that.
Gravity, but not instantaneously, like the ground stops B, right?
Oh, so you have to calculate the displacement.
So now you got to calculate the displacement that goes up above that. All right. So if you want a recreation of it, it's this. Let's see if this will work. I just set this up this morning and haven't had a chance to check it. So right now my two masses are equal. Lower all this. Am I happy with my setup?
I don't know.
Oh, I see. No, I'm not, because one of the things isn't on the pulley. All right, there we go. All right, so right now the masses are equal, so, oh, shoot. So everything balances. All right, but let's make our block B heavier. All right, so these masses are not going to exactly model what we're looking at over there. I'm going to go with 200 and 500 grams. All right, so here's my 500 grams. Oh, darn it, the weight just came off. Pulleys, you guys, are the enemy. They always fall apart like this. Okay, so here we go. So if I drop, blah, it came off again. No. What would make you ask such a thing? Don't laugh at me.
I got this. We're not laughing at you, we're laughing with you.
Nope, I got it. Thank you, Andrew. All right, we're ready. Are we ready? Thank you. I'm sorry. I literally, okay. All right, here we go. You ready? So watch what happens. This one goes down. Oh, did you see how it like jumped up? That worked perfectly. I'm really excited with how well that worked, right? So block B stopped, but block A sort of got thrown up into the air, right? Okay. So what do we need to figure out in order to figure out how far block A gets launched up into the air, you guys?
Initial velocity.
Okay, initial velocity. What do you mean when you say initial velocity, Michael?
The velocity of when the bigger weight hits the ground.
Good. We need to find the velocity of the two blocks when block B hits the ground, right? Oh, well, we know the acceleration and the time, right? So I feel like I ought to be able to find the final velocity as they fall, right? It's just VI plus AT, right? Where here's my VI, here's my A, and here's my T, right? So if you do that, it gives you like 2.4 meters a second. I think it's 2.42. Good? So to be clear, what that represents is the velocity of block B as it hits the ground, and therefore the velocity of block A as block B hits the ground. Good? And then the rope goes slack. So now we've got this. Here's block A. It's got an initial velocity of 2.42 meters a second. Eventually it's going to
Go to zero.
Stop.
go to 0. What's the acceleration that causes that?
Gravity.
Gravity, so negative 9.8 meters a second squared. So find your displacement using which equation? The 2a delta epsilon, right? So that displacement, if you figure it out, ends up being 0.3 meters. It's like 0.298 or something like that.
What are the rules for rounding in this class?
There aren't any. It's like freaking free for all. I don't care. All right, we're good? All right, so then what's the total height it gets to? 3.9, right? 3.6 because of this. And then from that point, it goes up another 0.3 for a total of 3.9. Does that make sense, you guys? All right, that's definitely a tough problem. Okay. I don't know that I would put something like that on a test because there really was a lot of processing there. And if you sort of didn't understand what was going on, it wasn't that you didn't understand the physics, it was just like, So. All right, are we good? All right, cool. So, I guess at this point, I'd like you guys to make a decision. So if you think you're good with the rest of the assignment, then when I say go grab a spot on one of the lab tables in the back and go ahead and get started on the review. Please, shoot, you know what I say to grab a spot at the lab table, but there's no chairs back there. What if I have everybody who still has questions on stuff that they want to go over?
I have one very short one.
One very short one? Are there people who want me to go over 5? I've heard a lot of people talking about 5. Do we even need me to go over it yet? So maybe, anybody else? All right, well then maybe I'll just go around and get individual questions then as needed. Does that make more sense?
Yeah.
Okay, cool. So you got, whatever, half an hour. Use it.